Happy Hanukkah. Uh, I'm starting the live stream a little early today so I can talk about some unfinished stuff from yesterday. Although I did solve it, I wasn't entirely happy with the solution, and so I thought about it a little bit overnight. I also wanted to share these great visualizations I'd seen from people solving day 4. So this is a solution in Clojure. It's visualized as a big grid. There's the first solution. You can see that the ones that are later mainly leave the diagonal open. I really like this one. This is just, this person is solving the problem with the graph grammar. And so here are the square graphs corresponding to all the input boards. I really like the style of this one. It's a very nice bingo board. It's really well done. This is kind of amazing. So this is the list code and its visualization all on one page. This is nice subtle Julia output matching the input of the examples in the advent of code. Here's another animation. Let me see if I can make this. I can't seem to zoom in on that. Anyway, nice animated GIF filling in all the squares. So one of the things I was unhappy with yesterday is that I had not really managed to write a lot of types to describe, what the function should be doing. And so I thought about it, and the way that was easier to reason about is if instead of simulating everybody in parallel and picking the first one who won or the last one who won, if we just simulated a card until it won and then kept track of how long did it take. So I wrote this predicate, and this is sort of a beefy predicate, but this is what I used further on. So it's recursively defined. It takes the list of numbers, a card, and an X, and it says, is X is turn X from the numbers the first time that this card wins. So recursively, either X is 0 and we're already a winner, or if X is 0 and less than the length and we've got some numbers left and we're not a winner yet, so this is what gives us the first win, then we recurse and, well, maybe the next move is the win. And if the next if we take the tail of the numbers and mark the card and decrease the index by 1, then that's an equivalent situation. And so with that, I was able to prove, for example, that given any smaller number, we haven't won yet, and that's basically just a simple inductive proof. And so here's our search function, and which just takes a list of numbers in the cards and says calculates what is that first number. And then this proof turned out to be not too complicated once it was written, but it runs very slowly in F star. So I actually had to get it to work reliably, had to bump up the amount of time F star is willing to give its underlying solver, and then pop it at the end. So use these pragmas, push options and put options and pop options to do that. But then again, this is at its heart just a fairly simple inductive proof. So what we're saying is, here's the function whose behavior we want to reason about. So if that returns the pair, time, and final card, then that was really the first time it wins. So we could maybe put this clause in the option field here, but I figured it was going to be hard to reason about it at the same time we were computing. Sometimes that works well. I didn't think it would work well here, but you know, basically, if we just tell it, hey, this is how you do the induction proof, it figures out all the intermediate steps. I thought I was going to have to maybe prove some of these things in the middle with assertions, but it turns out uh, as long as the time was cranked up high enough, it was fine. So um, I put the results. I couldn't get a dependent triple to work, so this is what I've been doing instead of having a dependent tuple. And what so it's a dependent type, which means it's basically got arguments, and the type of later fields can depend on those arguments. So a win record is depends on the context of the list of numbers we've got, and it records a card, and then it records a time, and that uh, predicate we put up ahead of time is attached to this time. So it has to be a specific time. It can't just be any time like a normal structure. It has to be a time where we've provided the proof that yeah, this is really the first time that that card wins. And I we could go further here. We could have the final type also have some qualification of say, yes, this is really what you get after you run through all the numbers up to time, but I didn't end up doing that. So this function is just filters filters out those that don't win, which doesn't actually happen in the problem as given, but it's a possibility we have to allow for, because there's no way to prove, hey, you're not going to be given an input that behaves well. You could write that as an assumption. I shouldn't say there's no way. You could write that as an assumption. So once we do that, then we can actually put a meaningful type on the minimum and maximum functions. So these just compute the minimum time and the maximum time from our list of records of how long does each card take to win. And it we can express again as a refinement type, as a clause attached to the type. Hey, uh, you know, I'm giving you this particular win record, and it has a special property that every other winner has a time that's greater. So it's they win later, just like we wanted. And I didn't actually have to do a lot of work. F star in this case was able to figure out that yeah, you know, that holds in the base case trivially because there's only one time, and if it holds in the inductive call, then this is sufficient to ensure that it works well. And if I had gotten uh, the sign wrong, then I think it's still waiting a second. Anyway, it's not type checking. Yeah, so we get a failure. The failure message isn't particularly useful, but it is okay. And so everything else is more or less the same as in the original solution. And this is checked in at part 3. So got a couple of minutes left, so I'll point you at my GitHub page. I've put all my solutions up there. I've included some links get information on getting started with F-star. I thought I fixed that link. I did fix that link. Okay. So F-star is a OCaml-like language. It shares a lot of syntax with OCaml. It's described in various ways as a language for proof-oriented programming, a language for reasoning about effectful programs as a dependently typed language, and we just talked a little bit about some of the things you can do with dependent types. There's the FStar homepage. So we'll get started in a minute here. Thanks for watching. Advent of Code is sponsored by, among many others, my employer this year, Akita Software. We have a lot of open job positions. Be glad to have you apply to come work for us. My link is in the chat. I've been trying to get an ASCII art Akita to match the ASCII art Santa Claus hat, but haven't managed to come up with that yet. All right, screen share back on. We are just seconds away from Advent of Code Day 5. Welcome again. I'll be trying to live code the solution in FStar. It may take a while. It's taken a while on all the previous days. So maybe this year, today it'll be easy. Okay, so we've got lines of events. Those are inclusive. Only consider horizontal and vertical lines. Good. Line drawing algorithms kind of suck. Okay. By suck, I mean they're hard to implement well. All right, we need to find the number of points where at least two lines overlap. All right, how long is our input? Fairly long. Not too bad. All right. Numbers go up to about 1,000. So I was worried about this because the one thing I don't think FStar has is a really good dictionary structure. For sets, it uses OCaml's batteries included set, which is pretty good. But I was looking at the map implementation, and it didn't seem like there was a lot of Okay, I'm confused. What are we supposed to do with the ones that are not horizontal or vertical? We're just supposed to ignore them? Okay, I guess so. At how many points do at least two lines overlap? All right. Oh, at least two lines. So we don't actually, for part one, have to count them. We just have to put them in a set. And maybe two sets. All right, let's get started. I'm wondering if I can skip the parsing. Probably not. Right. So let's make a record. So So we'll define, this isn't, I'm wondering if this is the wrong way to do it. Maybe I should just make it a record, but I'm not super conversant with the record format. It gives me trouble every time I use it. Tuples records. All right, let's do it that way. X1, X2. X2, Y2. All right. All right, so let's write a function to parse these from a string. I'm going to copy my integer parsing from yesterday, since that worked okay. It would be awfully nice if that arrow were something else. So I'm gonna fix that actually. I'm just gonna make it easy on myself, and that arrow, oops, is just gonna become another comma. All right, good. And I'm actually gonna have this be able to return an error. If length, okay, we need f star dot if nums is not equal to 4, then so a record initializer looks like equals instead. So equals equals text. I'm pretty sure I'm getting some things wrong here, but we'll type check it in a second. Dot. Okay. Have that backwards. Huh. I don't like that. Maybe. Okay. Very good. Okay, we finished parsing. Sort of. All right. Let's see. FD read list of line cards. So again, we'll copy. I really should just come up with a. Here is how you some helper function, some higher order function that does this for me. No, make that recursive. All right. Parse of read string. Read line. All right. Okay. So let's from a line, let's determine whether it's horizontal or vertical. Running both Python and Go instead of F star. My fingers just want to do the usual thing. All right. So it's horizontal if the x coordinates are the same. It goes left to right or right to left. I guess we haven't been guaranteed that they appear in order. That might be the case in the input. Okay. So that's if line all right, back to the tutorial dot notation. Line.x1 equals line.x2. All right. So let's write something that returns the list of intermediate points. Let's return all the points on line. And that's as a pair of integers. All right, and what we'd like to say is that every pair is between the endpoints. So the point which is a pair of integers. Let's define a point. All right, so either p dot. All right, I think this will be easier if we knew that these were in order, and we can't always swap them around. We could get x1 before x2, but they could be sloping either way when it's. All right, so the type will get a little more complex. Let's write a between predicate. Um, so that means a less than or equal to n and n less than or equal to b, or b less than or equal to n and less than or equal to a. So whichever order they appear in, we're covered. All right, so for every point, either px equals I should be using the logical and, not the Boolean and here. So if it's a horizontal line, which you can write there, so is horizontal line. So our type return type actually depends on our input type. And between p dot I got these backwards. Horizontal is the y coordinates the same. Okay. Let's see. Okay, so it's horizontal, and between the x coordinates between line to x1 and line to x2, or the opposite. And so the only way we can guarantee that is if it's already one of those. We can't change the type of the input. All right. Crud, we're having to count integers again. All right, so let's do this recursively. Okay, if let's do this recursively. So what I'm planning to do is move the endpoints closer together, picking up a point each time. So we're going to decrease. Do we have absolute? We do. Line. So we have to guarantee that the function terminates if we're going to make it a total function. All right, and we're going to do that by moving the endpoints closer together in the, I forget, is this the L2 norm or the L1 norm? We're just taking the Manhattan distance. All right. All right, so line dot. If they're equal, then we just return that point. Else if we're horizontal, then we return. We have to know which way we're going. So if we're going left to right, then we pick up this. this is turning out ugly. All right. I think there's a special syntax for this actually. Yeah, with. All right, let's give that a try. So it's equal to line with x1 equals, what did that look like? With x equals p dot x plus shift, which is basically what we're doing here. Okay. And our next case, be nice if the match worked on this, but okay. And then we need to do the two vertical cases. So if line dot y1 less than line y2, then take the first point and then y1 equals increment along the y-axis. Otherwise, decrement on the y-axis. All right, let's give that a shot. See what S star thinks of it. It thinks I've got a syntax error. Okay, yes, the refinement has to go inside the parenthesis. Oh, I've run into this. The record syntax has to go in parentheses if it's being used as an argument to a function. I don't really know why. Else if okay, we need to make that a singleton list. Oh, phooey. Okay. I wrote it as if it was still pairs, but I had switched to the point type. All right. Oh, phooey. All right. All right. Well, so now we're starting to run into trouble with using records. So it's calls the constructor and says, "Hey, that's just a point. How do I know it has this type you have?" So let's do what we should have done instead of copying and pasting and create a let statement. So first point, which is of this type, which we might want to write a definition of if we're going to reuse it a bunch. So that's equal to all right. That is a very long error message. All right. It just says it couldn't prove. Just couldn't prove it. Let's try proving the parts one at a time. Um, so it should be the case that line.x1 is between line.x1 and line.x2 because it's equal. And it should be the case for y. So whichever way we go, we should be good. Same error. Okay. All right, I goofed up. So we can't do this. I made this mistake before. We can't do this recursively because it's a different line each time. So the type of the point we're putting in is changing each time through. And so, all right, so we can fix this. So we'll keep our original line and our subsegment. We're going to prove everything we need to know about this subsegment. Might be better off pulling out my integer range function, even though that has similar problems. Okay. All right, this the way I'm thinking it'll be easier if we okay. Okay, so we need to know this is which means it needs to be the second argument. Okay. So if all right, so if we reach the end, we just return the singleton list. XP plus, and on this say lines first. Okay, so if we're going left to right, then that's how we handle it. Otherwise, we're okay. dot x2. Field name. I being inconsistent on underscores versus not on underscores, and it's tripping me up. All right. Hey, so that one type checked. And it's kind of gross, but we know it. We know it returns only points between the given coordinates. And it seems like we should be able to do a search and replace, but not everywhere. All right, good. Does type check. That is way more complicated than it needed to be, but I think we can have somewhat greater confidence because we wrote the type of what it was supposed to do. Now, it doesn't actually guarantee that they're all there, which would be an even more complicated type. So I'm not going to get into that. Let, and then we'll just tie them together. All right, I'm going to do what I should have done and say let find the type. All right, so everywhere we've got that, we can just say it's a list of point on line. So we gave that type we were working with a name. So this will be somewhat shorter. All right, still happy? Still happy. All right, and what we'll do here is we'll handle any line and just leave this blank for whatever we do with diagonals when they show up inevitably in part 2. If is horizontal, it's on horizontal line L. Okay, we need to give it the first coordinate. So that's going to be x1. Yeah, we terminate when we reach the second coordinate. Good. All right. So now that we know all the points are, we need to do the ones that occur more than once. So we'll use a set. We'll use oops. That work? All right, can we describe this as a type? So we want a set of points that, of all the points that have appeared on any line, and we want a set of those that have appeared on more than one line. Sure, I think we can do that. Let me look at the set documentation. Not much there. All right. So we need it to we could use a dependent tuple or track both the point and the line, but we don't actually want to track the lines. We just want to track that one existed. Okay. And we'll points on 2 lines, so we need two lines not both equal. So L1 not equal L2. So let me think about this for a second. If we only store the point and not the line it belongs to, then we're going to have trouble proving that they're not equal. Which is unfortunate. We could store a set of all the lines and say, it's getting kind of tricky. I was going to say we could store a set of lines and prove that everything that was unique because it wasn't in that set. I think we have to make this type depend on that set. All right, I'm not really happy about this, but I mean, because this is trivially solved by anything in points on some line, right? We could use the same line for both, but I don't see how we would prove that they're different. Okay. All right, so we're going to process this. Process the list of line coordinates. And I'm going to build up these two sets. So S1 points on some line and S2 is on two lines. And we want to return a set of points on two lines. All right. Well, let's see how far we get. So it's just simple iteration, recursion over the list. So if we're all done, we return S2 Otherwise, we got to process this point, which we'll do so by okay, we need to recurse over the lines and we need to recurse over the points. And so I'm going to do both of them. It's too difficult. All right, I'm going to... Because we made our point on line type dependent on the line. So we need a line to refer to. And the easiest way to get that is just have it as an argument. So list points are a list of points on line. And our two sets. And we're going to return updated versions of those. Okay, so if we're done, then return S1, S2. Otherwise, if, okay, how do we check set membership? Mem, right? Mem, yes. So if that point, let's call it P, if P is in S1, then we need to add it to S2. So process points on line, tail, same line, tail, I believe I looked at this before, and the only way is to do a union with a singleton. It's kind of annoying, but union S1 singleton P. Oop, oh, wrong one. We're adding it to S2 here. Otherwise, we want to add it to S1 and leave S2 alone. So now's the moment of truth. Will this type check? It does type check. So it took care of and said, again, I think trivially, yeah, I can satisfy this in everything you've added to in making this union with the singleton. All right. So okay, so now we're processing the lines, and so let the points equal points on some, oops. Okay. So yeah, we just take a standard line. We get a set of in points on line. Get the line, the point S1 and S2, and then we recurse. Points. Go back. Tail is first new sets and second new sets. What are you unhappy about? All right. So does this have a way of telling how large they are? Oh no. Oh, we could create it from a list too. That's all right. Well, shoot, I thought we could grab the list cardinality. Huh. This seems a surprising omission. I mean, you could deal with infinite sets this way. I'm not seeing it. There's no way to turn a set back into a list. Let me check the implementation. Yeah, it's not bound to anything in the OCaml. Well, crud. Okay. All right. So we'll track a list. Okay, this will return. No, I guess we did need it both places. Right, so this will return a triple instead. And so when we're going to add something to S2, we'll check, is it already a member? So if okay, so if it's already a member, then we don't need to do anything. Otherwise, we're adding it to the list. All right, so I'd like to write a type for this that sort of expresses it's the same as the things in the set. That might actually be easier. All right. Okay, so we've got a list of points, and every point is a member in our set. List is set S2. Phooey. This is gonna cause us grief because we gotta. Now we've made this tuple a dependent type, a dependent tuple. All right, let's try it out anyway. The dependent tuple is a semicolon. We need parentheses around the whole thing. Oh, it's not semicolon, it's and. There we go. Ampersand. I'm still not sure how I make a dependent tuple. Concrete syntax is okay. This documentation is out of date, I'm pretty sure. Fortunately, the tutorials don't use either version. Where's the wiki? There it is. All right, maybe it's a moot point because it doesn't seem like our Okay, so we guaranteed, just copied the type in, so type in the list. All right, now we're back to not being able to construct. That's not helpful. Syntax. All right, it says correct syntax for defining a pendant pair type is that, but it doesn't say what syntax for key. All right, let me try like. All right. Okay, so we need to do this in 2 steps. New S2 equals. It was complaining there wasn't a type match. This is probably going to be more trouble than it's worth. We have the same problem as we're changing the type, and it doesn't know that. It doesn't know it matches. All right, let's go back to. That would be a nice thing to get working. Is just to guarantee that those went together. We'd probably want to create some wrappers around them to make that all work. Okay. So need the same thing here. Um, what is the syntax for getting the third element? Dot underscore 3. Okay. So let's try it out. Let's parse our input. Now we want this to return L2. Okay, let duplicate points equals process points. So our list, our empty sets, our empty list. We may have to give it some type hints there. I load printf, I did not. Don't actually need to load it. I could just number. And that's list dot length of duplicate points. All right, let's guess we do have to open it. Too many arguments. Oh, okay. It has an implicit argument, and that's enough. Okay. Let's load up an example. The example from perform our simplification on it. See what happens. All right, is 5 what they said we should get? Yes. All right, let's try it on the real input. don't know if there's any way to get it to take a command line argument. We might be able to get one from OCaml if we wrote the library ourselves. All right. Well, let's see how it thinks about that. All right, right answer, first time. All right, and as expected, we need to handle diagonal entries. So let's preserve our part 1 solution. So I was thinking about this, and can our type be more general? So it should be the case that if it's horizontal, then one of these are always equal. That 3 of these are always equal and 1 varies. And now that we're diagonal, we should be in a similar situation. So let's just see, if we push that through all the way, does anything complain? No. Okay. So I think we're good there. So let's write our corresponding to this version for diagonal. So we need 2 points. And we're going to decrease some of our absolute differences. All right, but do we have to handle all 4 cases, or is there something smarter we can do? All right, so let our direction of x equals if one else. So that's direction from the first coordinate to the second coordinate. So we're sort of building in the assumption that all right, our type's kind of loose. It allows anything in the square. And really what we'd like is to be more specific and say we're some distance along the diagonal. So both are increasing by 1. But I'm not going to go back and fix that. That would add a lot of complexity. But I just want to point out our type is not restrictive enough. It would allow a lot of incorrect behavior. Okay. All right. This is significantly simpler, so maybe we should go back and. All right. It didn't like our y coordinate. Why not? Oh, that's just the first one it's got. All right. I think I know what'll help is if we say we get to either endpoint, then we're done. Yeah, that was the problem. All right. So if it were if we're not 45 degrees, this would be completely wrong. But like I said, we'll live with it. All right. So everything else should be good. Let's check the example. Okay. Says it should be 12 points now. Good. That's the right answer. All right. How did we do tonight? Personal. Yeah. We picked up 1,600 ranks between the parts, and our best showing yet. So the puzzles get harder. My inexperience with S-Star doesn't hurt me as much, I guess. All right. Well, I'm going to call it a night, I think. I don't see any questions in the chat. Thanks again to all the organizers and sponsors of Advent of Code, including my employer, Akita Software. That's our logo in the bottom right there. Check out our job page if you're interested in working with me and other great engineers. That didn't sound very modest. I apologize. So I and my giraffe t-shirt are going to bid you happy Advent and happy Hanukkah and good night.